With projectile motion, the most common one is when you've got a particle, so it can be any kind of an object, a tennis ball or whatever it might be, but treated as a particle, is projected at an angle theta or x, whatever you want to label it, right? With an initial velocity u. That's the most typical way you'll see it in questions, all right? The word projected, right, means that it has initial velocity, all right? It's not from rest. So I'll put that here as a note. Projected means has initial velocity. If something is allowed to drop or is released, right, it means there's no initial velocity. Initial velocity is 0, all right? So u equals 0 in that scenario, all right? Okay, so in this one, what you're going to have usually, and let me just do that, is some sort of a parabola like that. I know that's not quite symmetrical, but it's meant to be, all right? And the rule, as I said earlier, when we were talking about it, is that this initial velocity is at an angle, all right? And we tend to resolve this into vertical and horizontal, all right? Like that. So vertical and horizontal components, okay? And again, use whatever notation you want to, whatever's in your textbook. The horizontal component of velocity at any given point, all right, is going to be resolving that, right, using the angle. The vertical one is u sine theta. Okay? Oh, my apologies. My apologies. I've just gone the wrong way, haven't I? Apologies. So the horizontal is cos theta. All right? So that's going to be, let me just change colors for a moment. That is u cos theta. And the vertical component is u sine theta. All right? Okay. The important thing, this one here, right, is constant. There are no forces due to air resistance or anything else, right? That's one of the assumptions in the projectile motion that you're going to be working on, all right? So that's not going to change all the way through until the projectile hits the ground again, okay? That horizontal velocity remains constant, okay? The vertical velocity initially, all right, will change. Now here, you need your equations of motion, and I'll explain where this comes from. If we start with, you remember v equals u plus at,
Yeah.
all right? So u plus at as your format, I mean, that's where it comes from. The u in this case is u sine theta, all right? So that's the initial velocity. And then your gravity, remember, if I do it like this, is acting downwards, right? So compared to your initial vertical velocity, gravity is opposing it, right? So in this one, we put your acceleration is minus g and t is time, okay? So your vertical velocity at any given time, right? T is time in seconds after projection. Okay?
Yeah.
Does that make sense so far?
Yes.
All right. These two are fundamental in the way to like dealing with projectile motion. All right. Okay. Now, the horizontal one doesn't really do much for us. There's nothing we can very much use it for. Okay. It's this one that's important. Okay. Because there are several things about this particular motion that you can find out from using the vertical velocity equation. One is time of flight. And this is almost every single question you come across. This thing is really, really essential. Okay? Basically, it means how long does it take for the whole thing to go up and come down again? All right? And you remember from equations of motion, you've got S equals ut plus half at squared. So S is what in this case? What is S generally?
Distance. Distance.
Displacement. Close.
Yeah.
All right.
Sorry.
Yeah, cautious because that can be negative. All right. So S is displacement. So what that means is that if we now put in our projectile motion values into this, okay, the S is effectively height. Above the point of projection. Okay? So that is, right? That's what we're using it as. And remember, the initial velocity in this case in the vertical plane is u sine theta. All right? Acceleration was minus g, so it's minus half g t squared. All right? So that will always give you, after t seconds from projection, the height above or below, whatever it might be. If it's positive, it's above. If it's negative, it's below. All right? Does that make sense so far?
Yes.
Okay. So it's always using the vertical component. Okay. The point then is that for S, right, S equals 0 means that it's either t equals 0 at the initial point, right, because the vertical height is 0, right? Or t equals, call it a big T, i.e. whatever time for the given information that you have, right? This is the time of flight, in other words, how long the projectile was in the air. All right? So we can solve, if you have all the values, you can solve for t, right? Oh, hang on. I've forgotten something. There's a t there. You didn't spot that. You should have corrected me.
I saw it, but I didn't say anything because I don't really know too much.
Doesn't matter. If you see me make a mistake, correct me by all means. All right, so the time of flight. By having the big T, if you find out what that is, then the horizontal distance, if I go back here, the total horizontal distance that the projectile travels is simply the VH, so u cos theta, times that time of flight. All right? Does that make sense?
Yes.
Yeah? All right. The other thing that we can use, so this is point one, one aspect of the information analysis that you can do on a question. Another thing, when you have the projectile at maximum height, all right, that one, we go back to our v equals u plus at. So we know that vertical velocity equals u sine theta minus GT. So I just remind you of that one there. Yeah, or that one there, yeah? Okay. So that minus GT. All right. At max height, the vertical velocity, the velocity at which it's going up, right, equals 0. Okay. Therefore, u sine theta equals GT. Okay. And rearranging that, we can find that T equals u sine theta over G. All right. And the beauty of this is usually now all of this that I'm saying is in the context of a symmetrical sort of like projectile motion, right? So it starts off at a level and it comes back to the same level, right? Therefore, the max height will always be half times time of flight. Okay, so if I go back to my diagram, so somewhere there, if that's my maximum height, right, that will also be half of the time of flight. That thing there. Does that all make sense so far?
Yeah.
Yeah? Okay. So whenever they ask you a question, it's like find this or find that, etc., always consider the vertical motion first, because that's the one that's going to give you the most information, all right? And that you can actually use to find other elements of the motion. Okay? Any questions on that so far?
No.
No? All right. The other types of projection that you're going to get, right? For example, non-symmetrical ones. Hang on. Right? They sometimes say, like from a cliff top, right? And that one, you can have projections. For example, sometimes say something is thrown out horizontally, all right? So you've got u horizontally. Now with this one, the horizontal velocity is not going to change, okay? But you can guess from here, the thing's going to drop down like that, yeah? So in other words, its initial vertical velocity equals 0, all right? But it's going to accelerate. Acceleration is going to be g downwards. So even though initially the vertical velocity is 0, it's going to start accelerating, okay? Another one that you get from the cliff top type of question is there's an angle like that, okay? And again, it's theta from horizontal, if you like, okay? And it's the same thing, okay? Like that, maybe, all right? The point here is that they may give you the height of the cliff, all right? And so your position at the end of the motion, when it hits the ground or sea or whatever it is that typically comes up in a question, the distance, horizontal distance, you can work out from the u or whatever it is, right? But your displacement at this point, right, at landing, your s, right, your displacement relative to where you started, where the projectile was projected from, is going to be minus h. Can you see?
Yeah.
Yeah, it's going to be below the level it started at, okay? And as long as, it doesn't matter whether you call it h or minus h, as long as you are aware of the negative signs and what direction you have set in your question is positive, all right? Does that all make sense?
Yes.
Yeah? Okay. Another thing that is important, again, a typical question, is that if you have the speed versus velocity. All right, 1 second, and resume there. So speed versus velocity. One of the typical questions they give you is that at a particular point in the motion, something like that, right? For example, at this point here, all right, what is the speed? All right, or what was it? Find the velocity. All right, the overall velocity at a given point. Okay. In order to find the speed, it's just the magnitude of velocity. Does that make sense? Yeah?
Yeah.
So in other words, if you've got a particular velocity, let's say where I've put it, like that, right? So that's your overall velocity. Okay. In order to find that, you would have a horizontal component and a vertical component. So in your projectile motion, remember the horizontal one is always u cos theta, and it's constant. All right. This bit, you need to work out what the vertical velocity is at that particular point, using either time or height, whatever the parameters they give you. All right. Once you find that, right, and remember that's VH. So the magnitude of velocity, if they want the speed, is going to be using Pythagoras, right? It's VH squared plus V vertical squared and then square rooted. Okay? Does that make sense?
Yes.
Yeah? All right. I'm not going to labor the point there. And in terms of finding the actual velocity, not the components, yeah? It's sort of like what I've just explained there. The horizontal component is same, as we've just said, okay? You find the vertical bit, right, up or down, whichever direction it is. So using VV equals U sine theta minus GT, so therefore you need T, all right? Or if they give you what is the velocity when it reaches, I don't know, 2 meters above the ground or something like that, okay? You can use, or you need to find, I suppose you could do this, V squared equals U sine theta squared minus 2GH. All right, well, that's a height, and therefore you need the height above ground or whatever the situation is. Okay, so if you find those components, and this one is okay, VH. So again, finding those, you can find the magnitude of the actual velocity. All right, as we've shown just a couple of minutes ago, we talked about speed, but this time you need one extra bit of information. And you need the, call it X or alpha, yeah? Whatever you prefer. It's the angle compared to the horizontal that it's traveling at, yeah? So the direction of travel, right? Let's say equals alpha degrees to horizontal, okay? That will be given by tan alpha equals the vertical component of velocity divided by the horizontal component of velocity. Okay? Does that make any sense?
Yes.
All right. So with that information, you can define the full velocity with the speed, i.e. the actual velocity magnitude, and its direction. Okay? That is more or less everything that you need theoretically for projectile motion. All right. Any questions on that so far?
No.
No? All right. I'll pause there then.